Chapter 5: Elements in Times of War. Despite supernovas exploding elements in all directions, and despite the best efforts of the churning molten earth, some places ended up with higher concentrations of rare minerals than others. Sometimes, as in Ytterby, Sweden, this inspires scientific genius. Too often, it inspires greed and destruction, especially when those rare elements find use in commerce, war, or worst of all, both at once. The science of good and evil. Using chemicals as weapons started in ancient Greece when the Spartans tried to gas Athenians into submission with the most advanced chemical technology they had at the time: smoke. It didn't work. Chemical warfare progressed slowly for the next 2,400 years until World War I. By then, many countries recognized the threat of chemicals, and all the scientifically advanced nations in the world, except one, signed the Hague Convention of 1899 to ban chemical-based weapons in war. But the one holdout, the United States, had a point. Banning gases that at the time were hardly more powerful than pepper spray seemed pointless if countries were still all too happy to mow down 18-year-olds with guns and sink warships with torpedoes and let sailors drown in the dark sea. Nevertheless, the other countries signed the Hague Pact and then promptly broke their word. Early secret work on chemical weapons centered on bromine. Bromine especially irritates the eyes and nose, and by 1910, military chemists had developed bromine-based chemicals so nasty that they could bring a grown man to his knees with hot, searing tears. Since the Hague Agreement concerned only warfare, in 1912 the French government decided to slow down a group of Parisian bank robbers with ethyl bromoacetate. Word of their capture quickly spread to France's neighbors, who were right to worry. When war broke out in August 1914, the French immediately lobbed bromine shells at advancing German troops. But they didn't have any more luck than the Spartans did. The shells landed on a windy plain, and the gas had little effect, blowing away before the Germans realized they'd been attacked. However, it's more accurate to say the shells had little immediate effect, since hysterical rumors of the gas tore through newspapers on both sides of the conflict. The Germans used the rumors to their advantage, blaming one unlucky case of carbon monoxide poisoning in their barracks on the French, for instance. Their goal? To justify their own chemical warfare program. Thanks to one man, a bald, mustached chemist, the German gas research unit soon outpaced the rest of the world's. Fritz Haber had one of the greatest chemical minds in history, and he became one of the most famous scientists in the world around 1900 when he made a discovery that changed the world. He figured out how to convert the most common of chemicals, the nitrogen, element 7, in air, into an industrial product. When Haber invented a process to capture nitrogen, he was able to turn common air into ammonia, NH3, the chemical used to make fertilizers. With cheap industrial fertilizers now available, farmers no longer were limited to compost piles or dung to nourish their soil. Even by the time World War I broke out, Haber had likely saved millions from starvation, and we can still thank him for feeding most of the world's 7.5 billion people today. But Haber was interested in more than fertilizers. He actually wanted cheap ammonia, which is NH3, to help Germany build nitrogen explosives. It's a sad truth that men like Haber pop up frequently throughout our history, those who twist scientific innovations into efficient killing devices. Haber's story is darker because he was so skilled. After World War I broke out, German military leaders recruited Haber for their gas warfare division. Though set to make a fortune from government contracts based on ammonia, Haber couldn't throw away his other projects fast enough. The division was soon referred to as the Haber Office, and the military even promoted Haber, a 46-year-old Jewish man who converted to Lutheranism to help his career, to captain. Dozens of young chemists volunteered to work with Haber. Germany had fallen behind the French in chemical warfare, but by early 1915, the Germans had an answer to the French tear gas. The Germans tested their shells on the British Army, not the French. Fortunately, as in the first French gas attack, the wind blew the gas away, and the British targets had no idea they'd been attacked. The German military wasn't giving up and wanted to devote even more resources to chemical warfare. But there was a problem. That pesky Hague Pact, which political leaders didn't want to break, again, publicly. The solution was to read the Hague Pact in a bogus way. When they signed it, Germany had agreed to, quote, abstain from the use of projectiles, the sole object of which is the diffusion of asphyxiating or deleterious gases, end quote. So, to the cunning Germans, shells that delivered shrapnel and gas were okay. It took some engineering. The sloshing liquid bromine, which evaporated into gas on impact, was tricky to control, but Germany prevailed, and a 15-centimeter shell filled with a compound called xylyl bromide, another horrible tearjerker, was ready by early 1915. The Germans called it Weisskreuz, or White Cross. Again, leaving the French alone, Germany swung its mobile gas units east to shell the Russian army with 18,000 Weisskreuz. If anything, this attempt was more of a failure than the first. The temperature in Russia was so low, the xylyl bromide froze solid. After 2 failures with bromine, Haber redirected his efforts to its chemical cousin, chlorine, element 17. Chlorine sits above bromine in group 17 on the periodic table and is even nastier to breathe. Because chlorine is smaller, each atom weighs less than half of a bromine atom, chlorine can attack the body's cells much more easily. Chlorine turns victims' skin yellow, green, and black and attacks their eyes. They actually die of drowning from the fluid buildup in their lungs. If you thought bromine was unpleasant, then chlorine was a whole new level of nastiness. Enemy soldiers soon had to fear the chlorine-based Grünkreuz, or Green Cross, the Blaukreuz, or Blue Cross, and the nightmarish blister agent Gelbkreuz, or Yellow Cross, otherwise known as mustard gas. Not content with scientific contributions, in April 1915, Haber directed the first successful gas attack in history, which left 5,000 bewildered Frenchmen burned and scarred in a muddy trench near Ypres. In his spare time, Haber also came up with a horrible biological law called Haber's Rule to help calculate the relationship between gas concentration, exposure time, and death rate, which must have required a depressing amount of data to produce. Despite having Haber, Germany ultimately lost World War I and was universally denounced as a scoundrel nation. The international reaction to Haber himself was more complicated. In 1919, before the dust, or gas, of World War I had settled, Haber won the 1918 Nobel Prize in Chemistry for his process to produce ammonia from nitrogen. The Nobels were suspended during the war. A year later, he was charged with being an international war criminal for his campaign of chemical warfare that had maimed hundreds of thousands of people and terrorized millions more, a contradictory, almost self-canceling legacy. He was never brought to trial. Humiliated at the huge compensation that Germany had to pay to the Allies, Haber wasted 6 years trying to extract dissolved gold from the oceans so that he could pay the bills himself. Other projects sputtered along just as uselessly, and the only thing Haber gained attention for during those years, besides trying to sell himself as a gas warfare advisor to the Soviet Union, was an insecticide. Haber had invented Zyklon A before the war, and a German chemical company tinkered with his formula after the war to produce an efficient second generation of the gas. Eventually, a new regime with a short memory took over Germany, and the Nazis soon exiled Haber for his Jewish roots. He died in 1934 while traveling to Palestine to seek refuge. Meanwhile, work on the insecticide continued, and within years, the Nazis were killing millions of Jews, including relatives of Haber, with that second-generation gas, Zyklon B. Modern wars. While some elements such as bromine and chlorine have been used in war, other elements have caused, or at least assisted, wars, and not in the remote past, but very recently. Fittingly, 2 of these elements were named after Greek mythological characters known for great suffering. Niobe upset the gods by bragging about her 7 lovely daughters and 7 handsome sons. The easily offended Olympians then slaughtered the children. Tantalus, Niobe's father, killed his own son and served him at a royal banquet, reason unclear, and as punishment, Tantalus had to stand for all eternity up to his neck in a river with a branch loaded with apples dangling above his nose. Whenever he tried to eat or drink, however, the fruit would be blown away beyond his grasp or the water would recede. Still, while elusiveness and loss tortured Tantalus and Niobe, it is actually a large excess of their namesake elements that has decimated Central Africa. There's a good chance that you have tantalum, element 73, or niobium, element 41, in your pocket right now. Both are dense, heat-resistant, non-corrosive metals that hold a charge well, qualities that make them vital for cell phones. In the mid-1990s, cell phone designers started demanding both metals, especially tantalum, from the world's largest supplier, the Democratic Republic of Congo, then called Zaire. Congo sits next to Rwanda in Central Africa, and you may have heard about Rwanda's terrible history of genocide in the mid-1990s when hundreds of thousands of people were murdered. In 1996, the ousted Rwandan government spilled into Congo, seeking refuge. At the time, it seemed only to extend the Rwandan conflict a few miles west, but eventually 9 countries and 200 ethnic tribes were at war in the jungles. Congo is a large country with dense forests, which make fighting a war difficult. Plus, poor villagers can't afford to go off and fight unless there's money at stake. Enter tantalum and niobium. Congo has 60% of the world's supply of the two metals. In the ground, they mix together to form a mineral called coltan. Coltan is then processed to get pure tantalum and niobium. Once cell phones caught on, sales rose from virtually 0 units in 1991 to more than 1 billion by 2001. The West's hunger proved as strong as Tantalus's, and the coltan's price grew tenfold. People purchasing coltan for cell phone makers didn't ask and didn't care where the coltan came from, and Congolese miners had no idea what the mineral was used for, knowing only that white people paid for it and they could use the profits to support their favorite warring tribe. Unfortunately, that wasn't even the worst of it. Unlike the days when crooked Belgians ran Congo's diamond and gold mines, nobody controlled coltan, and no fancy equipment was necessary to mine it. Anyone with a shovel could dig up whole pounds of the stuff in creek beds, like in the days of the gold rush. In just hours, a farmer could earn 20 times what his neighbor did all year, and as profits swelled, men abandoned their farms and growing food and instead started looking for coltan. This upset Congo's already shaky food supply, and people began hunting gorillas for meat, making them virtually extinct. But gorilla deaths were nothing compared with the human suffering. It can be dangerous when money pours into a country with no government. Without laws and clear rules for how that money could be used to help the Congolese population in general, a brutal form of capitalism took over in which all things, including lives, were for sale. The worst times in Congo were between 1998 and 2001, at which point cell phone makers realized they were funding anarchy. To their credit, they began to buy tantalum and niobium from Australia, even though it cost more, and Congo cooled down a bit. Nevertheless, despite an official truce ending the war in 2003, things never really calmed down in the eastern half of the country near Rwanda. Overall, more than 5 million people have died in Congo since the mid-1990s, making it the biggest waste of life since World War II. The fighting there is proof that, in addition to all the uplifting moments the periodic table has inspired, it has also been a source of some of the worst.